Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Today we would be discussing section 3.1.23 performance and internal working of a CPU. Components of a CPU. In the last lecture we discussed that according to architecture there are three main components of a processor or a CPU. ALU, arithmetic logic unit, CU, control unit, and MU or memory units, which consist of many registers. Now we are going to have a look at some other important components of CPUs which have been included in the new syllabus. The first of them is a system clock. What is a system clock? It generates clock cycles which synchronizes all of the computer operations. Increasing the clock speed of a computer increases processing speed. However, to increase overall performance, the width of data and address bus should also be increased. Timing signals or clock cycles are generated by a small piece of quartz embedded inside a chip on motherboard and are broadcasted through the control bus. What happens is that inside the computer on motherboard there is a special chip which contains a quartz crystal. Now it is the speciality of a quartz crystal that when an electric signal or electricity is applied to it, it vibrates. The good quality quartz or the higher quality quartz can vibrate millions of times per second. So this is what determines the speed of a processor. Like when we say 2 gigahertz processor, so it is basically the frequency at which the system clock or the quartz crystal inside the system clock vibrates. The higher the system frequency, the higher is the number of instructions that the CPU would perform, because on every signal the system or the CPU performs or solves one instruction. Overclocking. Clock speed can be increased in order to increase processing time through BIOS, basic input output screen. However, increasing clock speed too much, more than what the CPU was designed for, can cause overheating of the CPU, which can cause system crash, and it can lead to unsynchronized operations where one instruction can't be executed before the cycle ends and the next instruction is fetched, hence causing a clogged queue of instructions at the CPU, making it unstable, which can cause system crash or hardware crash. The next component of CPU is a cache or cache, however you want to pronounce it. It is a special type of high-speed memory that is found within the CPU chip. It stores data and instructions which are frequently needed by the CPU. The larger the cache size, the better the CPU will perform. Modern day CPUs have up to 3 levels of cache to make performance faster. By modern day CPUs, it means the cored computers, Core i5, i3, i7, i9, and so on. The level 1 cache is fastest, level 2 is faster, level 3 is fast. Just remember that even the level 3 cache is faster than the RAM. Now cores. What are cores? With the advent of improved manufacturing techniques, manufacturers were able to pack more CPU transistors on a chip of same size and build more complex systems. Since such innovations brought a solution where multiple CPUs were packed within a single CPU chip, which used just a single socket. Each CPU inside of a processor is called a core. Using a cored CPU considerably increases system performance. Now what happens is that this is, let's suppose, motherboard of a computer. Now when after Pentium series the scientists wanted to develop more faster computers, So first of all, an idea was proposed that we should add more microprocessors to the motherboard. But then again, microprocessor is the brain of the computer. A person cannot have two brains, a person cannot have two controlling units. So this idea was dropped. This would cause, they both would try to control all the available resources, and it would cause a disaster. So practically this idea was not much applicable. So instead what they did is they decreased the size of the components of a CPU, and in the same size chip they were able to add, or they were able to design more than one processors. The size of the CPU chip remains the same, but inside, instead of one, they were able to fit in two CPUs, and this was or two microprocessors, and this was called a cored CPU or core i3. The initial core i3. i3 means there are two cores. i5 would means 4 cores. i7 would mean 6 cores. i9 would mean something like 8 cores, and so on. And now each of these cores have their own ALU, their own CU, and their own memory unit or cache. ALU, CU, and cache. So these core, but they are inside a single chip. So these cores are able to perform faster rather than having a single core CPU or a single core microprocessor. Factors which determine speed of a computer: number of cores in processor. If you increase the number of cores, then your performance would increase, as each core has its own ALU, CU, and registers. Increasing number of cores increases computer performance. However, doubling the number of cores will increase computer performance to some extent, but it will not exactly double it. Why? Because between the cores the data need to travel. So if this is an, let's suppose this is an i5 and it has 4 cores, they need to be joined together. Each core would need to be connected with rest of the 3 cores. So this would mean that the data would actually be spending more time traveling between the cores instead of actually being processed inside a core. So this means a 2-core processor and a 4-core processor would not have twice the performance. If a CPU is 2-cored and another one is 4-cored, then this does not mean that the 4-core processor would have double the performance. It would have slightly better performance, but it would not have exactly double the performance. Similarly, a core i9 having 8 cores would not be working at double the speed of a core i5 having 4 cores. Width or bandwidth of address and data bus: more the width, more is the amount of data that can be taken in. Speed of internal clock: higher the speed, then faster would be the processor. Cache size: larger the cache size, larger would be the amount of data instantly available to a processor for processing. And the fifth one, increases in size of RAM. Now remember, just increasing any one of these factors is not enough. Your PC would not perform faster. Instead, it might be overheated or there might be some problems. If you want to truly increase the performance of your system, you need to take care of all these factors. You need to increase the number of cores, you need to increase the bandwidth, you need to upgrade the speed of internal clock, you need to upgrade your cache size, and you need to increase RAM. All the factors together, then your system would actually be faster. If you just increase any one component or any one factor, then you would not get your desired result. The next is we have 3.1.4 instruction set. An instruction set is a group of commands or operations for a CPU in machine language. An example of an instruction set is the 86 instruction set, which is common to find on computers today. Different computer processors can use the same instruction set while still having different internal designs. Both the Intel Pentium and AMD Athlon use the same 86 instruction set. Each operation or set of commands is made up of an OP code and an operand. OP code is the first part of an instruction that tells the computer what function to perform, and it is also called operation code. OP codes are the numeric codes that hold the instructions given to the computer system. Operand indicates the computer system where to find the data or instruction, or where to store the data or instruction. For example, STA1C. STA stands for store, so it is saying store the value at 1C. This would be a memory location. Now remember that instruction set is always have two parts with a space in between. The first part is the OP code or operation code, and the second part is operand. OP code tells the computer what to do, what task to perform, what operation to perform, and operand tells the computer where to store the data or from where to retrieve the data. So STA1C means store the number at memory 1C. INP, now there is no operand. So when there is no operand, it means the computer wants the data to be stored in accumulator. INP, this is OP code. Input a value and store in accumulator. Add 1C. Now add is the OP code and 1C is the operand. It means que add together the inputted number, which is currently stored in accumulator, to the number stored in location 1C, and find the answer. Okay, this marks the end of section 3.1.4. I hope you have understood. If you have any problem, feel free to ask me. Take care. Allah Hafiz.